Hey everyone, good morning. Thank you for joining us in this presentation. Today we'll be sharing how the core features of Apache Iceberg powers analytics and algo innovations at scale in Netflix Studio. In this talk, we will take you on a journey to explore and learn about applications of Apache Iceberg and how it is integrated with our data ecosystem. We'll cover the design implementation of storing high-dimensional embeddings in Iceberg and share how Iceberg unlocks reliable and efficient data processing patterns. A little bit about us. Let me introduce myself and my co-presenter, Dao. My name is Ryoshi. I've been working at Netflix for a little around 4.5 years. Dao and myself work in the same horizontal team that spans studio and creative production. Our team's mission is to build foundational datasets that empower Netflix Studio to produce content at scale, at the right time, cost, and quality globally. As a data engineer, I get to know about the process of filmmaking and how a script is brought to life. It's incredible how by leveraging data, we can enhance production workflows and make them even better. Dao?
Thank you, Surashi. My name is Dao. I've been working at Netflix for the past 5 years, working on the same team. My main focus within our studio creative production domain is around production business data collection, production media data mining for the purpose of machine learning and algo innovations, and then partnering with our data platform team around repurposing our data platform abstractions for streaming to be used in our studio space, where the business challenge and data challenges are a bit different than what we encounter on our streaming side. Back to you.
Thank you. Our favorite movies, like Bridgerton, starts with an idea, known as pitch, goes through different phases, and then finally lands on a service, which we call play. Every title's journey in a pitch-to-play lifecycle is unique. Data collected in various stages of a production lifecycle plays a very critical role to streamline operations and enhance the quality and relevance of the content produced. The rich information available in scripts before filming or media assets generated after filming could help in understanding the movie's genre and content category. For example, whether the movie is a thriller or a rom-com or both. All of this data, the tens and thousands of tables spanning content and studio business applications, land in Iceberg. Now let's dive into the data landscape, and we'll focus on the three phases, which is pre-production, production, and post-production. In pre-production, it is mostly refining the scripts, taking hiring decisions, and all of this data lands into Iceberg. In production, we have cost reports, production reports, assessing the execution health of a production, media files, all of this data as well is ingested into Iceberg. While in the post-production phase, we have editing and sound mixing. Footages captured during filming are aligned with music and sound effects. Asset metadata lands into Iceberg. So in a nutshell, Iceberg is the Netflix analytic data warehouse. And some of the questions we are trying to answer from the data that lands in Iceberg are, like a couple of them I can say, is how many productions will be starting in country X in time period Y? Or has script understanding been helpful in tagging content and predicting VFX shots? So let me take you through this process of how we create a well-curated data warehouse in Iceberg. Let's look at an example data pipeline setup that brings in data from internal studio applications to Iceberg. Towards the center of this diagram, you'll notice Data Mesh Enrichment Processor, which is a studio data movement abstraction framework built on top of Flink. The essential components of a data mesh architecture is the source connector, the enrichment processor, and the sync connector. So it can connect to a variety of data sources. It can enrich it using the GraphQL queries. Say, for example, you have the source events coming from different source applications, which has a movie ID. And that movie ID can be used to enrich that particular event with more information from different studio applications using GraphQL. like, for example, extending it with the movie title or the movie genre. And then the enriched data lands into Iceberg for further processing and transformations using Spark and Trino query engines. And then it is used for many analytical needs or ML use cases downstream. You can read more about the data mesh architecture in this blog cited below. Now let's take a closer look on change data capture and schema evolution that is happening in this pipeline. So the complete record that captures the latest state of an entity is stored in Iceberg in append mode, partitioned by date, hour, and batch. Because it is landing the data in append mode, it is very important to take care of the performance of the read of the queries that are reading data from those tables. So in Iceberg, when the after the data lands in Iceberg, we build compaction views that only selectively rank the records based on the timestamp of the records and create views. And so there are compaction jobs that run regularly, which will actually help in storing the latest version of that particular data set from the table. Now, coming to schema evolution, we are using Avro. So Avro is well known for being a serialization and deserialization, very good in that. So let's say, for example, you have additional columns, additional fields coming from source systems, or any modifications, any renaming of fields or dropping of fields. Those are handled gracefully in Iceberg. So that's the main advantage we get of integrating Iceberg into our data ecosystem, and it alleviates a lot of pain from data engineers in handling table maintenance activities. But there is no one-size-fits-all approach. Now, as I mentioned, we are creating compaction views on top of the tables, and there are different sets of users using Spark and Trino. We know that the data that is landing into Iceberg could be highly nested because it's coming from the graph source, graph service. So once it lands into Iceberg, it is important to unnest it, to rename certain fields, to do casting of data types, to make sure it is in a proper queryable format. And for that, we need to create views separately in Spark and Trino, because Spark and Trino has different SQL semantics to unnest the data. And hence, there is a lot of duplicative views that exists in our data warehouse that is used for different use cases. For downstream Spark ETL jobs, we use the Spark compacted views, and for the ad hoc jobs or more near real-time use cases, we use the Trino generated views. Now let's take a look at a specific use case. Say, for example, using the approach I mentioned earlier about landing the data in Iceberg, the raw event data in Iceberg, and creating the views, Spark and Trino views on top of it. After that, we also need to have the batch data pipelines listen to the snapshotted data. So at the end of the day, what was the latest state of a particular entity? And for that, we have daily jobs. And those daily jobs, they are using Spark insert override feature, where the insert override is actually is actually replacing the entire partition of that particular data set. And we are unable to actually figure out what's the exact change that has happened. So insert override works on the partitioning scheme defined on that particular table. And the same insert of override approach is used in other downstream cases where we want to take, say for example, a summarized view of that particular daily snapshot. So in this case, if we want to do a backfill, it's costly because we need to read all the events that have come for that day and then transform it and aggregate it, summarize it, and make sure all of this data is validated across the pipelines. Recently, you might have heard about the incremental processing framework that was built by the data platform team at Netflix. So using the incremental data processing framework, we are able to actually capture some references to the partitions that have changed. So using the ICDC framework, and if you see from the raw event source table, we are able to leverage the ICDC functionality, which is the incremental change data capture functionality, which actually stores the references to the data files pertaining to the partitions that have changed. And so if we have a more near real-time workflow, let's say, for example, on a 15-minute cadence, if we listen to these particular events that have come, and we know like what changes have happened. In this case, the raw event source has partitions on the date, hour, and batch. So we know that data. We can create a Spark data frame and make sure we capture it with the existing, we compared it with the existing data that is present already in our ETL table and generate the latest version. This actually helps in reducing the duplicative views that were getting created earlier. And this same latest version table could be used downstream. And for example, in our daily workflows, we are using merge into. Merge into is an Iceberg feature that we can leverage here. And it's more of like replacing the exact data files rather than working on the entire partition of the data. And so merge into can be used not only from the for the near real-time use cases, but also for the batch data feeds, where we can capture, we can know what data has exactly changed as part of that job run. And if we know what data has exactly changed, it is very easy to include auditing capabilities as well in a very narrow data domain. So that improves the auditing capabilities of the workflows as well. And using the ICDC framework, and you can read more about the incremental processing in the blog post here, we are able to streamline auditing and modernize the data pipeline a lot. And the existing workflows can be like replaced using this particular technology. So we are actually looking forward to productionalize this and make sure it also works for backfilling. And so this proof of concept has really helped us in improving our data pipelines in Studio. Also, I would like to talk about rollback, since it is merged into, let's say, for example, you have replaced the data files for a narrow set of data points in the table. And so it is very easy to go back to a snapshot to roll back if there are any unforeseen changes that have happened. So it's a good implementation from a data pipeline perspective and from a table maintenance perspective. Next, I will go on to schema interoperability. So far, we've spoken about ingesting data from Studio applications to our data warehouse in Iceberg. And now we'll go via the opposite route, which is, let's say, for example, in Iceberg, we have derived some data points, some metrics, which are not available in the operational world. So how can we expose this data back to the Studio applications? Earlier, there were bespoke workflows that used to expose this data to the Studio applications, but now we have a framework, and it's by using light transformations in materialized views where we create a kind of interoperable data contract, where, let's say, for example, the tabular structure in Iceberg is now converted to GraphQL and gRPC, and this particular data set is stored in memory. And then the Studio applications can use the GraphQL format to actually integrate that particular data point, the derived data metric, or the dimension, which is useful for operational reporting purposes, directly in the Studio applications. And it is a consistent framework that is being used across Studio applications to expose data from Iceberg to the application. So in this way, you can democratize your insights in business applications. Now, I'll ask Tao to take it over about screenplays.
Thank you, Surashi. So in these next slides, we will be deep diving into a specific project where we work with movie screenplays from across our Netflix original library. In this section of the talk, we will be talking about persisting the structured text data into Iceberg tables as inputs into large language models developed by our ML research colleagues. Talk about how Iceberg is used to enable experimentation for the outputs from such models by the research community at large, as well as smart partitioning strategies that enable these outputs to be queried in an efficient fashion in Veltrino by such research personas. Next slide, please. So just to start with some background, what is a screenplay? A screenplay is essentially a roadmap for how a movie is produced. All productions start with a screenplay, and it is used throughout the production lifecycle to inform various properties that is necessary to bring a piece of content to life on our service, from budget and size of production, which informs the number of scenes, prompts, how many characters are actually in the show, the production schedule, which involves location and the time frame that is necessary to produce the show itself. The subtitling and dubbing via the dialogues that are in the screenplay, as well as creative insights, everything from what sensitive content that might show up on the show, the rating, as well as the complexity of the production itself. So here, just want to give a quick overview of what is a script. So on the left side, you see the Word document that is an actual movie script. And you see that it is a very large Word document. However, with Hollywood, there is a very strict writing format, which enables you to parse each individual part of the script and structure it as a piece of data that could then be useful for our ML researchers. However, so here you see that the first line, Professor West, is indented a specific way, which actually then denotes that it is a character entity from the script. Later, you see that right afterwards, with a separate indentation, you then have a dialogue, action, dialogue cue, shot cue, page number, scene, and character description. All these are parsed by our application partners, and then leveraging the abstractions that Surashi just shared earlier, and warehoused into our data warehouse. However, working with the raw parse data has a lot of challenges. The amount of text versus signal is very low. The text is also too long to be fed directly into most machine learning models. And historically, it's not very obvious how to encode all the information that is encapsulated in a screenplay so that it's machine ingestible. So enter the script understanding model. This is a large language model developed by our research colleagues on the algorithm engineering team. And this is used to generate outputs that could be fed into other machine learning models, as well as generate early signals about a show based on the content of a screenplay. So here is the basic data flow of how the model is used to infer insights from a script and generate embeddings. So with the script corpus lives in Iceberg as a data set that then is fed through the script understanding model, and two types of outputs are then generated. human readable signals that categorizes a show's storyline, genre, and tone based on the screenplay text into a predefined set of tags that are maintained by our content editorial teams. The second type of output, which I'll talk about in more depth, is the machine readable embeddings. It's a numerical representation of the screenplay text that could then be fed into other ML models downstream. These outputs are then saved into Iceberg tables that enables researchers across Netflix to experiment with them, leveraging Trino, which is one of the paved path that used by our researchers to access data in our data warehouse. Lastly, as new screenplays are submitted to Netflix via our internal applications, inference is then run on those new screenplays to generate additional embeddings and tags on a nightly basis. So since we persisted this data in Iceberg, there are some challenges with using Trino as a way to query this data. Because of the large embedding field value, where each row is actually a 1 by 256 list of doubles, Trino workers can very easily go out of memory, and as a result, your query don't run at all, or in a performant fashion. So working directly with my research partners, we used an arbitrary batch ID to further partition the script embeddings into smaller files in S3 so that they could be queried in a performant fashion. A second challenge is, since new screenplays are turned over to Netflix all the time, we were able to leverage Iceberg time travel queries to essentially enable our downstream stakeholders to lock the input into the models they're experimenting so that they don't have to worry about changes on their future data set overnight as new script for a movie might be submitted. Lastly, this is all very nascent research and development efforts. So rather than putting this into in-memory data stores or into other types of databases, Iceberg was a very low-cost way for us to enable ad hoc experimentation, particularly in an OLAP pattern, across different Netflix verticals in content and product, for us to gauge the product market fit. Zooming out, I want to tease some future applications for some of these innovations that we are developing and researching right now. Firstly, as we start seeing usefulness with these embeddings, we have started the discussion with our machine learning platform team about integrating the embeddings into their platform as part of their platform offering, so that this will enable our algo researchers to utilize these text embeddings alongside the audio, video, and image ones that were generated from the Netflix content catalog. So this will unlock further innovations around multimodal type of algo projects. Secondly, working with our internal application teams to productionalize some of the research that we've seen that seems to be very promising. Going back to the pitch to play pipeline, we are looking at here are some ideas. During the pitching process, building an interface within our pitching internal applications that would enable our content teams to gain a better understanding of what shows Netflix has produced in the past that's similar to a pitch based on the semantic understanding of the screenplay creative it's pitching to us. In pre-production, these embeddings as well as tag values could be used as part of the input into generating early production budget and schedule estimations, which ultimately means that we could have shows that are made on time and on budget more often. Lastly, surfacing insights around characters during production that could inform casting decisions at the beginning of the production stage. And then in post-production, really insights around visual effects workloads so that the right visual effects partner is engaged before in an early fashion. All very exciting innovations that would not have been possible if we had to invest upfront in a lot of different infrastructure to persist and socialize this data across our research community at Netflix. With that, thank you so much for listening to us today.
Thank you, everyone.
Thank you, Shrashi and Dal. That was really, really interesting. I'd like to open it up to the questions from our audience. So you can type them in the Q&A tab to the right or ask your questions on camera. I'll just fire some out to you. So someone's asked, currently Trino queries get stuck in the workers. Are they lost during a query? How do you handle query resilience due to worker issues? Who wants to take that one? No one?
Yeah, I could maybe help answer. So when Trino queries get stuck, if the workers are lost during a query, we do have a log of our data platform do have a log of the actual Trino query that gets run. So there are ways to retry this through some of our internal abstractions. However, maybe to your point, there's a reason why Trino is not used directly in our production environment by our applications to surface data because of some of these concerns that would mean, our applications might not be able to fulfill their SLA. So as Shrashi presented in the query in schema and interoperability slide. This is the reason why we have an in-memory DB when it comes to surfacing Iceberg data using the schema as a contract within our internal applications. Let me know if you need a clarification.
Thank you. And also, is there a particular reason your researchers use Trino but Spark? I think there was someone else who asked about that as well.
Yes. A lot of times our ML researchers are thinking about, and this is by my experience in the past as well, generally if you're an algo or ML researcher, you just want a select star query to really get to your data. Additional business logic tend to be a huge barrier for them. Or you provide them an API that allows them to easily access the data they need for their models. And they found that the code startup time with Spark really prevents them from getting the data they need in a timely fashion. And a lot of times when it comes to distributed systems, they're trying to pull all their data onto one single VM. So they're not really taking advantage of a lot of the native distributed Spark, distributed workload offerings from Spark that really makes it easy for them to use Spark.
And also to add to that, the data analysts and the ML researchers spend a lot of time doing iterative development, writing ad hoc SQL queries. And so Trino is a good place to go to execute such queries and develop prototype solutions and make it very iterative in nature. So that's why I think Trino is a go-to query engine for them.
Well, thank you. Also on here, is there some optimization you had to apply at scale when using merge into statements? An example would be merge subsets instead of whole chunks.
Yeah, so we did actually make use of the exact changes that have happened upstream to make sure we actually replicate or replace the data files that have actually changed and not replace more. So yeah, so there were optimizations applied in the queries before actually merging the data into the base table.
Thank you. Also, how do you back up and restore Iceberg tables? Are you able to restore tables from one environment location to another? Are you able to restore specific partitions from backup copies?
Yes, I find this feature really helpful because things can go wrong in the production environment. And so if you look at the history of Iceberg, just typing in, just extending the Iceberg table with snapshots or history, you can see the snapshots at that point in time and be able to run audits across that snapshot. We at Netflix use the WAP pattern, write, audit, publish, so we can actually make sure that we run our audits, extensive audits on top of that particular snapshotted version, and then publish the final data set to production. So yes, I think that helps a lot for production use cases.
Thank you.
You can let me know if you have more questions regarding that.
Thank you. Also, how do you back up and restore Iceberg tables? Oh, I've just read that one. Sorry. I've moving my mouse around. Oh, that's why it's jumping. How do you achieve near real time in Iceberg when ingest data from Kafka? What actual latency do you achieve?
So far, we've seen the data flowing into Iceberg. It's in the range between 5 minutes to 10 minutes. So there is some latency, but all of our use cases are mostly like near real time. So if it is like within 15 minutes, it actually caters to majority of use cases. For cases that really need more uptime, more availability, more low latency, I think we go for solutions like, for example, the in-memory data store, where you can just query the graph and store it there and make it available for studio applications.
Thank you. And for ICDC, what happens if you get a lot of streaming data and it takes over 15 minutes to refresh?
So we are leveraging Maestro as the scheduler workflow, which has inbuilt features. So let's say, for example, you get a surge of change partitions. And so we use the for each loop to actually chunk those partitions into different data sets and make sure like we parallelize those data processing workflows, the sub workflows, so that everything, it actually executes the write, audit, publish pattern on each chunk at a time. So that way we are able to parallelize operations and make sure the merge into operations work smoothly there.
Thank you. And also, if we've got time for some more, oh, it's just jumped again. It's jumped again, it's moving around. Could you please share the core skill sets and knowledge that capable data engineers or senior data engineers should have in order to perform their job well?
I think I can go first and Dow can, jump in as well. To me, I think it's mostly like understanding the business and also being very curious, being very communicative is what really helps me as a data engineer, because we have to partner cross-functionally and understand what data can be leveraged to improve the business decisions. And also Iceberg, I mean, we are looking forward to evolve our data pipelines to make use of Iceberg's latest features, Spark 3 features. So we are always like learning more as these technologies evolve over time. Dow?
Yeah, so we actually recently did, actually not recently, but in 2023, we did a series of YouTube videos that really talks in depth about various verticals at Netflix and the type of work that we do in those verticals. So I will post that in the comment. I think that will be a very good primer in terms of the skill set and knowledge that would be required for a capable data engineer at Netflix.
That'd be really interesting. Thank you. Also, in which format is the data being stored? Are these text structured data? Do you have S3 and Hive Metastore?
Yes, we have things similar to a Hive Metastore, and our data is saved in S3. Though at Netflix scale, a Hive Metastore by itself is not sufficient.
Okay, thank you. And we've got one in the chat here. If you'd be working at a startup with limited resources instead of at Netflix, what would be the biggest challenges to get started with Iceberg, or what would you anticipate as challenging factors?
So I replied to this in the comment, so maybe I can go over just what I said. Was one of the bigger concerns that I've seen advising some startups is Iceberg's ability to integrate nicely with other off-the-shelf Spark solutions, such as Databricks or AWS native offerings. This is where I believe that Tabular could be very game-changing, since leveraging Tabular, this means you don't need to set up the data lake for yourself, and it will enable Iceberg to play nicely with other off-the-shelf technologies. At the end of the day, when you're working at a startup, you want to iterate very quickly and not spend your engineering time building infrastructure that will not support your core product. And something like a data warehouse is so commoditized today that if you want to build your own, unless you're doing a data lake startup, it might just be an inefficient use of the limited resource that you have.
Also, I want to add that the contribution model of Iceberg really fascinates all of us and the Iceberg community. So in any case, if we have a use case and we want to include that as a feature in Iceberg, that is so easy. I think that really helps to productionalize workflows and make sure features are available on time.
Thank you. One more here. Could you elaborate more on the schema evaluation process? Is it automated or requires manual intervention? What about breaking change, like dropping required field, which has downstream consumers?
Well, so regarding the schema evolution, so if it is, let's say, for example, a non-breaking change, you're adding a column, that flows through smoothly, right? But let's say if it is a renaming a column, then we create a new version of that table and validate that with the existing one. And once we know that the new version is good to go, then we make sure the downstream consumers have proper migration guidelines, and that is being taken care of downstream. So it is not fully automated. There is some manual intervention to make sure there is no impact to any critical workflows downstream. But the end-to-end flow from the source to the Iceberg sync for the new version is always automated through data mesh.
Cool, thank you. I think we've got time for maybe a couple more. So why do you prefer to use Iceberg versus a vector database to store the embeddings? What are all the benefits?
I think for us, because this was we were still seeking product market fit, it didn't, and the type of query pattern is very exploratory. We weren't 100% sure it was just going to be KNN or ANN type of query patterns, that it didn't make sense to invest in standing up a vector database, loading the embeddings into it, and then maintaining that going forward. If, say, in 2-3 quarters, we don't have to tear everything down. And so it made a lot of sense to use Iceberg as a low-cost solution to enable the querying and sharing of this data across Netflix by our algo engineering colleagues, without having to spend additional time and investment in setting something up.
Great, thank you. And I think we've got time for just one more. So this one's been pushed up to the top here, resurfacing the question, which apparently has been thumbed up quite a few times, so it's a popular one. Is ICDC utilizing Iceberg native CDC, or Is it a custom implementation? Curious to see what features it has over the current OSS CDC solution.
Sure, I can go with it. So it's actually using Iceberg snapshotting feature. And as I mentioned, it's very lightweight since it doesn't copy the data, the whole data that is coming from the source table, from where it's listening the events. It's just having references for the partitions that have changed. And that's all we need to make sure we apply the merge into the final table. And if you want to know more, I think I can give you more contacts around like how the implementation is being done in incremental processing. You can actually contact me offline for that.
Fantastic. Thank you. Well, thank you for joining us, and thank you to Sureshi and Dao. I think that's all we have time for today. Thank you for a great session.